Okay, so I'm going to tell you a bit about the story and what I went through over the last couple of years. I think there may be some hopeful things and can avoid you a couple of mistakes. Also, there will be a little bit of shiny to slowly transition to Colin's talk. Um, yep, here we go. So first, who am I? From 2008 to 2015, I did several degrees and studies around biology, chemistry, everything in between. There was a little bit of math stats. I was very multidisciplinary. And eventually I arrived at the University of Warwick, where I did a PhD in analytical science, so mostly chemistry related. And today I'm working as a Shiny R developer at Unai. So that's been quite a bit of a change, and I will tell you a bit how I got there and what happened over the last couple of years and the mistake during the PhD that I did. So my first contact in R was in 2013 when, during an internship in Vancouver, I came across wanting to do some mixture modeling on some data sets. So I asked the teacher about what was the best way to do that, and basically the exchange unfolded like this. And that's all. So I will let you know the experience wasn't successful there. I didn't have the knowledge, didn't really know how to use R, and I had really not much background about cluster modeling, so it was quite of a disastrous experience. Eventually, I reached this Warwick in 2014, and with a stats lecture, basically my R knowledge increased to this. That's basically almost as far as I got, and it didn't improve much more when in 2015, all I knew how to do was for loops, create function. I knew to do a base R plots, and I knew how to write a file, eventually figure or otherwise. And that's all the tools I had when I first started my PhD. And as you can imagine, it didn't really go well because I didn't have anyone to talk to. I didn't know where to get help. I didn't know how to get started with that. I didn't know what was a tool out there. So I just did with what I had. And after a while, I knew that it wasn't exactly the best way. There was much more tools, but I was struggling with a lot of deadline. I didn't take the time. And as you can imagine, it took 2.5 years till I created this monstrosity with many nested for loops, a lot of repetition, unreadable. And this particular script took about a week, and there was no user interface whatsoever to it. So looking back, what I realized I did wrong there was I tried to just use the exact same tool I had from the beginning. I didn't have anyone to contact because I was in a chemistry related department with a little bit of contact with statistics, but statistician doesn't always have the knowledge about data science and data manipulation that is required. And yeah, I didn't look for help. And as I said, I was favoring short-term deadline because I felt like changing my habits and the way I would do things would take me a lot more time till I finally was making up the time. It's like, when you wait the time it takes you to create a function versus the time it saves you. So, or, the time it takes to create a package and how much time it's going to save you. There was like always this thing about, oh no, I'm struggling too much. I don't have time for it. And yeah, it took me 2.5 years to get to the point where I decided that no. And also I wasn't using projects in RStudio, which was, looking back, one of the massive mistakes. And on the lighter mistake was like not using Git, but that is only, I would say, the lesser of all the problems I was going through and of the thing I didn't do. But then, due to an unfortunate accident, I heard about the tidyverse. So what happened is that a master student started working with me, and he started to learn R on his own. And when he looked for help, because we were now in 2017, at the end of 2017, beginning of 2018, the tidyverse had become a lot more prominent. And than what it was in 2015 when I started. And so he showed me about those cool new things, and I was like, wow, that looks great. So slowly I started to incorporate a little bit of those tools. But what I want to say is that if you've never heard of the Tidyverse, which now you probably are because I've heard of it more or less one way or another, it's a collection of packages which are really designed to work all together and to make going through between each of them really a seamless experience. So you can go from using one to other without even really realizing it. And once you learn how to use one, because they all share similar grammar, philosophy, and all that, it's really easy to get to know another one. So once you know a little bit more or less how to orient yourself with one of them, you can really easily learn all the others. And that's really, really useful when your specialty is not exactly programming and you have another goal, you want to do something else, like, I don't know, you're into any sort of science, journalism, whatever it is your field. If programming is just the tool that you need, that's what probably you want to be using. And so to really understand the philosophy around Tidyverse, going back to a talk I was at Hadley Wickham, which is at the origin of some of the package, and was one of the main contributions to the creation of the Tidyverse. What he said was that his goal with those package was to make a pit of success, that without doing anything, you will just bound to fall into this pit of success where you're going to just be doing what you need without exactly thinking how. So you can focus on doing what you want naturally without having always a hurdle of how am I going to do that. And eventually that's what happened when shortly after I came into the Tidyverse, I kind of fell into a bit of success. And here, what I want to share is how to do that, where to get started, and how you can fall in there as well. So first, you need to know that the R community as a whole here today is extremely friendly, and there's a lot of things going on Twitter that is extremely useful. Often, whenever I'm not working, just checking on Twitter, I regularly see tweets and things which are really helpful, like someone talking about a new package or some cool functionalities I found, or anything, or new talks coming around, or anything that comes there. There's always useful information, and just by casually glancing over there, you can sometimes solve problems you've had or you didn't know you had, and it can really, really be helpful. It's like just a little bit of following like a news feed, and it really, really, really changed everything the moment I started to follow a couple of people in the R community, and then it kept expanding across time, conferences, and interaction. So for that, I created a little like Twitter list of accounts, about over 30 accounts that I think are really, really useful, that you can go like without even looking, they are great people to follow, and you will get tons of information from there. So go ahead and check this out. Then you have a lot of information on RStudio, Stack Overflow, our bloggers. There's a lot of conferences happening. You have those meetups as well, but not only. Sometimes you have Saturday, which are more local and regionally organized. You have the Harley's Network and Aaron, the user conference. So really, there's always something that you can just tune in, listen, and you don't have to be proactive or tweet all the time. Just being there, listening will really take you really, really far. The other thing is to revise a little bit your Netflix. So if you've just finished Netflix in the last month, then that's probably a good occasion to start watching talks. Talks are a great thing to watch, like, I don't know, just casually or, in between a little break. They're often not more than 20 minutes, maybe some are about an hour when it's really like a keynote talk, but it really doesn't take you time, and some are really like life-changing. Personally, I found that talks from people at RStudio have been always really helpful, like Jenny Bryan and Hadley Wickham, but not only. And there's a lot of resources out there, so you can start with. So RStudio has published all their previous RStudio conference talks, And it's a great place to be. There's a lot of things. You don't have to watch everything. Just watch what's, get your interest. And for example, if I'm here working on United Days, because I just watched, one day I watched a talk from Nick actually at our studio conference, and that's how I first heard about the company. So it can really do a lot for you. And also the R consortium, since over the last 2 years, they've started uploading the talks from the user conference, which takes place every year. It's been cancelled, unfortunately, this year, but they have started to put the talks on YouTube. So same, it can be great to just glance over, see what's in the title, pops your attention, just watch one. If you don't like it, you can, always stop and restart it. It's really great. And also, sometimes you can press pause, check out whatever you've seen, and then resume. It's a great way of learning and improving your skills. And finally, I want also really emphasize on this step that you got to stop running at some point. Stop with picking short-term deadlines, because the moment you will stop and really look at your tools and your toolbox, things may accelerate a lot over time as you learn and implement those new tools. So the first place to get started is make sure you know just a few basics tools, know how to go around the user RStudio project, know that, where to find the documentation of a package, and knowing that you should never save raw data or use set working directory or mlist in a R script, or your computer may be set on fire if you know the reference. Or you can check out, I put a little link to explain what the philosophy is there. But there's really very few you need to know. And from there, you have strong, solid bases that you can build on. So always keeping an eye on new packages and new things popping out, or maybe even old package, but someone finds it and cool and shares it on Twitter, and you're like, oh yeah, we didn't heard about this before. So what I want you to know that the day I finally took a week to get my R skills sorted, I basically did more in a year than I had done in the last 2.5 years before that in terms of code. So there's obviously not everything was wasted. There was I found a lot of algorithm and all that, but eventually things really changed the moment I got the tools right. And also don't try to learn everything to think by taking a week you will learn everything. You just gotta get a good foundation and then just try to add one more thing. You find something new, incorporate it in your workflow. And when it's you're using it naturally, then try to add another one. Don't rush. And another thing is where to get started to learn. So the first link, the R4 Data Science, really takes you from scratch and brings you all the necessary skills and the good foundation that you need. What I discovered as well is that I was never taught what is a proper visualization. So if in your field you need to visualize a lot of data, there's a lot of things that we will tend to do naturally wrong because we don't have the right tool, because of many reasons. So the second link is a great place to get started. The second and the third to get started about knowing how to do a proper visualization. How to and give you idea about that for new figures, and because the moment you have the right tool, you will be able to do impressive visualization very easily. Finally, Studio has a lot of good tutorials and resources. Also, if you want to get started with Git, Happy Git with R, it is a great place to get started. And finally, R Markdown as well, which, if you need reproducibility, is really what you want to be doing. So so as I started to improve on my new tools, I had heard of Shiny. I knew about Shiny because I had seen it on RStudio website, but to me it looked very complicated. I would be spending a lot of time learning something that was just a fancy visualization, and in the end you don't really get a PhD for that. At least that's what I was told. Till eventually with the tool I had, I was always struggling because I need to visualize a lot of different elements, which to the point where I created a function that would generate all the plots I needed, write them as a picture file in a specific folder, and then I would open all those figures all at once and just use the arrows to go through them to see all the things I needed. And that was just like really cumbersome and crazy. And when I think about it, and how simple a little shiny app is can be done, and can just help you like interactively navigate through all the different cases and figures that you have, is just like, I wish I had known that earlier. So I will just quickly demonstrate that. For example, this is all you need to create a simple app. You just need a UI element that will define your panels and your setting, what the value, what you need to be changed. Then on your main panel, you will create your figure. Eventually on the server side, you just put your classic ggplot code and just put the input bin wherever these parameters that you want to be changing that is from the interface. And then you just start the Shiny app. And that gives you a really simple graph that you can immediately interact with. And you can see all different cases just like that. So really, if you have a lot of figure and you need interactivity in your visualization, really it's simpler than you can think, and really have a little go at it. You don't have to deploy a massive Shiny app there. It just can help you when you work in your workflow. And also, let's say it's really the important is to get the ball rolling, be on strong foundation, and starting to slowly add new functionality. For example, for a Shiny app, maybe just make it a little bit more complicated, adding one new feature, and don't try to be like, build the Eiffel Tower just all at once. Start with something tiny and get it done, get it solid, get it working, and then add something else. And then slowly iterate, and that will make you feel really good because you will be successful several times in a row. And this like steps of success will encourage you to keep trying to add new things and learn how to do new things. Obviously, it's not going to work the first time around, and it's going to be taking a bit of research, but as I'm saying, the journey is really the goal there, and it's all those things you're learning when it's not working, when you're trying to find out why, that really brings all the knowledge that you need. Because if you don't make it to work, if you don't understand it, you will have a big trouble getting it to work. It's often the moment you start to understand exactly the logic behind it, how it works, that you can get it to work and fix a problem. And that's really a good way of iterating and improving. And yeah, don't rush yourself there. Just add one more thing. Try to make it, a little bit more fancy, add a bit more tools, a bit more resilient. Often having a direct interaction with your user will be great. If you're not the final user, then try to be in close cooperation, because Shiny apps are always draft. They will be always improving and evolving. And because you start small and you don't necessarily have all the skills at first, and you don't really see the end picture, your Shiny app might grow into some monstrous atrocity. For example, it might end up like a R file with like thousands of lines of code, with like all your Shiny app into a single file. And then you will realize, oh, I've heard there's something called module, and then suddenly you realize like you can break it all down and then make like little pieces together, and then you will dismantle it completely, create your module, and then rebuild it all together. But that's a process. Like, don't try to aim to be ambitious all at once. And then eventually you may realize that you may need something else, like as a package, as you will see later. So what I will now walk you through rapidly is the example what happened in my PhD. So that first R script that I mentioned, I was trying to address that was a really complicated problem. So I will show you how I addressed that and how it turned out into a really useful and eventually a massive Shiny app. So what I was working on was with mass spectrometry. So in mass spectrometry, we measure the mass to charge ratio of molecules, of charged molecules. So the first thing would be to create ions, then we put that into an analyzer, and then we detect ions, and then we create a mass spectrum. Now, sometimes we may need to do something called chromatography to do with a separation technique. And when you do that, the problem is what I've shown you just before, one mass spectrum can be several gigabit file. Now imagine you're doing that about 1,000 times. That gives you really massive, extremely big files. And that's where I was stepping in. So for that, we use the ultra resolution. So ultra resolution in mass spectrometry is very, very useful because it allows us to see a lot of molecules that are very close together, that have a very similar mass. Sometimes if we have two molecules with the same mass but really close to each other, we cannot really make the distinction. So the ultra resolution allows us to do that. And the most complex mixture we have in the nature is petrol. Those are extremely complex, and they are great benchmark and places to develop new tools because we can find hundreds of thousands of different molecules inside a single sample, and that's really gets complicated for the end user, which doesn't have the right tool, because you cannot check each and every one of the thousands of molecules of peaks one by one. So you really need to have a global approach. So as I already mentioned, we have a massive complexity there. We have file size which can go to several gigabytes to dozens of gigabytes, and we have a lot of information. The tools are not necessarily like the information can be changing, the intensity sometimes can be changing, so we had a little bit of a reliability problem. And the tools were just not scaling at all because all the samples that the most tools are generated from use simpler samples and lower resolution, which means like the principles that were used to develop those tools were not scaling up. On the other hand, if you develop tools on this extremely challenging and at the edge of the field, then those tools will be able to scale downwards to simpler cases. So here we needed to use chromatography, as I mentioned, because mass spectrometry gives you only the mass and not the structure. And you can have molecules of the same mass but a different structure. And this is what caused some scandals in the past with, for example, with one being harmless and one causing birth defect, for example. So it's very important to be able to distinguish between those two. The problem is that we're already struggling to analyze one FTIR spectrum. Now we added almost 1,000. So that's where the Keros MS Shiny app comes in that we developed. And we made that into a Shiny dashboard. We had to make it asynchronous because some computation could be long. We have data tables which can have over 1 million rows because we have, imagine that you have already thousands of peaks present in about 1,000 of scans, which means you have millions of rows. So, and we made it modular as well over time. And the good thing is that it gives us a tool to really analyze the sample. And we really had to take in our own hands the software development because no company would do that because it's so cutting edge that there's not much of a market. And that was and it took about 1.5 years to develop this Shiny app to take it where you see it now. And it changed everything in the field and it's being used every day now. And because we were able to keep every single information and process it thanks to all this dplyr caliber Shiny tools, we're able to just by adding a single line to the dataset make some animation. And that was really mind-blowing for all the people in the field because they used to lose resolution and not look at information in this way. So suddenly we could see exactly what was coming out of the instrument. We can recreate the mass spectrum that comes out in real time and create and see the composition as it goes. But to get there, it took many iterations. It started out a single Shiny app, a single graph with a little cursor as you saw earlier. Not the exact figure, but that's basically the level of complexity things started, and that's the wow effect. Often you just have to show one little thing with Shiny where people can interact and play and see how responsive it is. And immediately they will give you the resources and the skill and the tools to do what you want because it's just not something people are used to yet. And here what was the strength was to be able to interact with users on a daily basis. So any new release would be immediately be put in use by users and they would say, oh, can you change this? This is not clear. And so it's always a draft, it's always a constant iteration, but that made it a tool that now a lot of people in the field wants to use because it just suits perfectly to the user. And that's really where Shiny is extremely powerful. But to get there, it took over 3 complete rebuilds. That means I had to take it completely apart and So it took several iterations there. Eventually, we found it complicated sometimes to add new features or different cases. So we started like splitting apps in the beginning when we were lacking the skills. So at some point, we started to create 3 shiny apps depending of what you wanted and the type of data you wanted to process. Eventually, by learning about the modularity and the changes we learned later, I was able to combine it into one that would adapt to the type of data. But it took several iterations. And right now, we've reached the end of it, of the current version, the way it is, and we are considering, and it's currently being evaluated to rebuild it as a full package, especially with Golem that made it easy for people which are not exactly familiar with package architecture or how to do that. It really it's a great way to give you the tools to know where to put the different pieces if you're not familiar with how to build a package, for example. So to summarize, how not to be a rookie. So keep in touch with the community like you're doing today and just, slowly expand it up. You don't have to talk with people or interact or post on Twitter. Just follow people. I'm not personally posting much. I'm using True Interact, sometimes ask questions. But yeah, just follow there. And then eventually, if you feel like sharing and starting postings, then go ahead and do it on your own pace. There's no pressure whatsoever. Also, make time for exploration. It really saves you a lot of time. I did more in 6 months after learning the proper tool than I had done in the 2.5 years. Honestly, this is really, really important. Don't feel like you have to learn all the tools and make everything that everyone's doing. Everyone's doing at their own pace. There's no the important is that you feel great and that you feel successful and you're encouraged into that. And yeah, don't hesitate to fail. Failing is normal. Error message are part of the process. You will always get error message. Just learn how to read them, understand them, and then fix. And yes, some will come back regularly and will be frustrating, but eventually we'll learn. Watching talks is great. I have to especially recommend any talks from Jenny Bryan and Adley Whitcomb because they are always really easy to follow, extremely interesting, really they bring everything to your understanding level. You don't have to be a really advanced user to understand them and get things out of it. And especially stay curious and try to discover and explore and try new things. And yeah, in no time you will be like this. Which I've linked the talk. It's a great talk called How You Can Do Data Science in a GUI. Have a look at it. And thank you for your attention, and I'm happy to take a couple of questions. And yes, Colin, I have a little message for you.
Thank you very much, Remy. Really enjoyed that talk, and I think it really resonated with me, actually, sometimes when I try to brush through things and get frustrated. So if I ever need motivating in my R learning stuff, I'm coming straight to you. Okay, so let's take a few questions before we hand over to Colin. There's a question from Willie who said, "Great talk, thank you. Remy, how are you making the Shiny app available for users? Do you publish the app using Shiny Server or RStudio Connect?"
So RStudio Connect is first in academia we don't have the tool for anything paid, so we've been using Shiny Server, like the free app, Shiny Server. And I found that if you have access to a simple Linux server, getting Shiny Server installed is really well explained on RStudio website. And it's really easy to publish it on that. You just have to put the right file, create an app.r. But then obviously if you're looking for things with control access, firewall, or you don't want to make it public, then that gets more complicated unless you start paying for example, Shiny IO and all those. It's all on RStudio website. They have a lot of tools to make it really easy if you're willing to pay. They also have a free plan, but which has if it has a lot of users, then it kind of restricts a little bit.
Cool, thank you, Remy. Any other questions before we hand over to our next speaker, Colin? Let's see, I'm just going to see if I can see any hands raised using the functionalities there, but I cannot. So yeah, thank you, Remy. Great talk. Cool.
Hey, I will just stop sharing and hand it over to Colin. Yep.
Brilliant. And I have unmuted Colin there now.
Okay, thank you, Remy, for your talk. Thank you, BristolR, for inviting me. So I'm here tonight to present you the golem package, which is a package which has been designed to build production-grade Shiny apps. So first of all, a little bit about me. So I work in a company called ThinkR, which is a French company focused on data science and R. I do also a lot of open source work, so you can find our website on the links. If you want to complain about what I'm going to say, you can ping me on Twitter at _Colin Fay, and you can find my open source work on GitHub under Colin Fay. So a quick introduction about ThinkR. So ThinkR is a company in France that does data science engineering focused on R. So we do training, we do software engineering, we do R in production, and we do consulting. And a big part of software engineering and R in production is building Shiny applications and then sending them into production. And the reason why Golem was born is out of an internal necessity for us to have a tool for these tasks where we need to do Shiny apps engineering that can then be sent into production. Okay, so basically, what does building Shiny apps look like? Basically, you're just building a proof of concept. So you have a piece of code that you're happy with, a little algorithm, and you want just to make it interactive, and then you show it to your boss, and then they are going to say, very cool, let's send it to production and make it available for 100 users, and let's make it, one big project for our company. So you're very happy with this proof of concept, but the truth is, with this proof of concept, this is what it looks like. So you're showing a beautiful front end that you've been building, you've been hacking away through building the Shiny application. So the backend is a little bit of a mess, and it can even be really a nice front end and really a nightmare in the backend. So why is that? The reason? What it leads to is, with these hacky Shiny application with hacky backends, it makes sending Shiny to production really hard because you have built a proof of concept, and it makes it hard to send it to production. The reason why is that you don't have the solid foundations for sending out to production. So you've got this beautiful stencil, which is a proof of concept of castle, but as you haven't built this castle with solid grounds, it's really hard to send it into production. So that's where Golem comes into play. The idea is that sending a Shiny application or any web application to production, you are more or less always doing the same thing. So building these solid grounds for Shiny applications that are made for production. So they have a lot of common patterns, so you are more or less always doing the same things. So the idea is that, as we say, if you have to copy and paste a piece of code more than twice, you should write a function. So the idea is that if you have to copy and paste an infrastructure more than twice, you should write a framework. So this is where Golem was born. So building a framework for these Shiny applications, for these repetitive tasks that we are doing over and over again when we are building Shiny applications. So Golem is an R package that contains a framework for building production-ready Shiny app. Sorry, I've got a lot of stickers, but I can't share them with you. So why would you use Golem? So basically, the idea is, first of all, to automate the things that are repetitive, so the things that you're doing over and over again. If you have to copy and paste, for example, if you are building a large Shiny application, you are going to use Shiny modules, but if every time you are creating a new Shiny modules, you are going to be in online documentation, copying code pasting it into an R script and then removing everything if you are copying and pasting code from somewhere else to your application, to your script, that leads to a lot of errors. For example, when you want to deploy, when you want, I don't know, to build a Docker file for sending a Shiny application to production, it can be really repetitive. It's error prone because because it's repetitive, so it can be boring to do it over and over again. So the idea with Golem is that all these things are abstracted away in the sense that they are automated. For example, building a Docker file, we are using the description file from your application to build all the necessary tools for sending your application as a Docker image on the server. Also, using Golem means that you are going to work with reliable tools, because as this is an open source, that means that anybody can come, use the tool, and give feedback. And anytime, of course, you have a new version of a package, people are using it and giving feedbacks, and they find bugs, and they want to, suggest new features. So the idea is that it makes the tool more reliable, because we are building, collective intelligence around this tool. And of course, it helps you gain time developing, because the more you can automate the things, the more you can concentrate on building what matters. That is to say, instead of having to check if you have correctly created the skeleton for a module, instead of, I don't know, spending 10 minutes just to check that everything is there, that the documentation is there, you just have to launch a function from Golem. It creates the skeleton and you can start working. You're not losing time thinking and checking things inside these really engineering tasks that can be automated. Of course, it's a simplified deployment, because, as I said before, for example, if you want to build a Docker file, we have worked a lot on these Docker files. It analyzes your code. It creates a Docker file, so it scans your description. It tries to get the system requirements. It makes all the installation for all the packages with the correct version, and then you just have to take your Docker file in your app and deploy it. You don't have to build it by hand. So that helps you simplify this deployment process, because if you're building a Shiny app, most of the time you are coming from our background, which is more an academic background, so you might not know really how it works to deploy things into production, what it takes to build a Docker file. So building a Shiny app with Golem, it helps you make this application more legitimate to your IT, because you can bring them with a Docker file, which is something they know. It's also standardized teamwork, because as it's a framework, it's standardized the way things are organized inside your project. And if you're working with several people, if you have several people working inside the same framework, that is, they're using the same tools and the same conventions, it's easier for them, for your team to work together. So as I said before, first, Golem was built at ThinkR as an internal tool. Today, this is something that we use on a daily basis. I think I'm the person that uses Golem the most. So yeah, it was an internal need in the beginning, but we decided to open source. We built it because we needed these reliable and consistent tooling for deploying to our clients' environments. Because when you do, even more when you are doing consulting and engineering for clients, you have various environments for production, you have various requirements, various configurations. So it's even harder than just working for one client when you have to work with several clients. So we needed to have something that can help with that. Of course, we wanted to build some kind of collective intelligence and share good practice about Shiny in production globally. So that's why we decided to open source it, so that we can globally work on this idea of Shiny into production, how we can build tools around this. And finally, we also wanted to promote R and Shiny in production, because if we can help people making R and Shiny a more legitimate tool for building production application. So that's for the best of the whole R community. Okay, so I've been, I'm gonna just like this. Okay, there. So I've been talking a lot about production-ready software, but what is production-ready software? If you think about what a production-ready software is, it has to have metadata, that is to say that you have to know what the version of the software is. It's very important, for example, for version control, for debugging and testing, because if you don't follow the version of your software, it's hard, to tell your clients what version are you using. Oh, I'm using the version you sent me last week. Are you sure was the version? Are you sure? So if you are using metadata, it helps communicate with your clients. Metadata also means the dependencies. What's production-ready software? Of course, it's divided in function because, as Remy said before, you can with Shiny you can end up with these monsters that is an application of thousands of lines. So this is something that is not production-ready in the sense that it's totally impossible to maintain a software which is just one big file. So, of course, if you are sending an application to production, you have to divide it in function because it makes it more easier to work on it and to understand it from a developer point of view. Of course, production-ready software is tested because you can't send something to production that is not tested, be it for the algorithm or the front end. Of course, it has to list the requirements. If you have system requirements, if you have all the packages you are depending on, you have to list it. And of course, you have to document it, be it for yourself in 6 months when you want to work again on your application, or for your clients that is going to use the application, or the IT that's going to deploy the application. So this is what I think is a production-ready software, and if you look at it, this is already built in our package framework. So if you think about what a package is has metadata, which is the description file. It's divided in functions and the R folder. It's tested, so you have the test folder in your package. You have the requirements in the namespace and in the description, and of course it's documented via the man and the v. So the big idea with Golem is that you are building a package that is contained inside a package. Why that? Because we didn't want to reinvent the wheel. We have all these tools and all these things that have been built for years for package developers, and all these people that have been thinking about it and that have been building tools for packages. So we want to use that as to stand on the shoulder of things that already exist. And of course, the cool thing is that if you are already a package developer, everything you know, it works with Golem. I mean, you are really building a package that contains your app. So everything you know about package development works in the context of Golem. You don't have to learn anything new from the package infrastructure point of view. It's really everything you know about package works with Golem. So if you start a new project with Golem, this is the structure of the project. As I said, if you are already a package developer, this is a structure that is going to look familiar. So you have a description, a namespace, and an R folder, which are very standard package files and structure. You have the R folder, which contains 4 functions, 4 R scripts, sorry. So you have this R folder that contains the skeleton of your app, which you are going to populate later on. app server, app UI are functions that contain the traditional server and UI. The run app is the function that launches the app. So how it works is that you are going to build functions that launch UI and server, and in the end, when you're building your package, you're going to have a function called run app. Of course, you can change the name, but it's the default name. And it's this function that is going to launch the app. So you have a package, you can install it on another machine or server, or even if you want to send it to CRAN, you can send it to CRAN and you have a function inside your package that launches the app. Something which is different from standard package is the dev folder. So the dev folder contains 4 files, which is a scripted workflow. So when you open the project, you have the start script that launches, and it's a series of steps you can follow just to be sure you are setting up everything. So as I said before, you don't want to have to think about all these things like setting the description, like, I don't know, all these standard things that you are doing over and over again every time you are creating a new app. It's in this start script. In the dev, it's the functions that you are going to use on a daily basis, for example, for creating a new module, for inserting a new JavaScript file, and things like that. The deploy is function for deployment, and the run dev script is a script that you can relaunch while developing. So basically, it relaunches the app so you can see what's happening. So what it does is that it helps you to remember everything, and also it helps you keep track of what you are doing. So, for example, in your dev script, you are adding module as your module. So you have a track of what you have been doing, what you have been working on your app. So in the inst folder, you have something which is new since the last version of Golem. So the O2 is the golem config.yaml file. So it's a file that relies on the config package. So it's a package with which can read YAML files for different configurations. For example, if you are deploying something to a server, you have environment variables, and this config package helps you. For example, you can set production or development, and you can read different values based on these environment variables. Okay, so I said that there would be a lot of automation, and of course there is a lot of automation in Golem. These are, for example, what you can do to automate your workflow with Golem. There is an add module function. What it does is it creates the skeleton for a module inside our folder, so you don't have to think about how to write it. You just launch this function and it creates the skeleton. Add CSS file, use external JS file, and add JS handler. These are all functions that helps you deal with JavaScript and CSS. So the add CSS file and the add JS handler, they create an empty JavaScript and CSS file that you can use, and they use external JavaScript file. You're specifying an external JavaScript, for example, from the web, and it puts it into the right folder at the right place inside your application. So this is also something which is kind of hard when you are building Shiny applications, is that if you want to add some CSS or add some JavaScript or use an external file, you have to think about where to put it, how to link it, and things like that. But with Golem, if you are writing add CSS file, you can write your CSS in the file and it's automatically linked to your application and it's put on the right place inside your package. So you don't have to think about how to link and how to use them. They are just there and you can start working on what matters, let's say building your CSS to JavaScript or things like that. For the deployment, we have function to deploy to RStudio Connect, Shiny Apps IO, Shiny Server. We also have add Docker file for Shiny Proxy and for R-ookie. So the idea is that it takes your package, it analyzes everything inside and creates, the Docker file or the files that are necessary to deploy your application. So this is, for example, the add module function. You just say golem add module name my module, and it has the file in R mode module. What it looks like is this. So you have your UI and you have your server. And the cool thing is these 4 lines at the very bottom of your file, which are the code you have to copy and paste to your UI and to your server. So you don't even have to think about how to name it or to name the ID, and to be sure that it matches from the UI and the server. So you basically just go and put it in the right place inside your application. So you don't have to think about to check that these things are correctly set, and it helps you on the long run because you don't have to debug silly thing like an ID that doesn't match. So now, hopefully, sending Shiny to production looks a little bit more like this and not like a big battle. What's next for golems? Of course, it's a work in progress. We have, if you find any bug or if you have any ID, everything is listed on the GitHub repo. If you want to help, anybody's welcome to contribute, be it for bug correction or for piece of code, for an ID, for anything. So everything is on the group GitHub repo, and you are very welcome if you want to contribute. So of course you can spread the word and share stickers. If ever we can get out of our house, I would be happy to share stickers. Of course, you can tweet, you can talk to your friends and families about Golem, because you might be lacking, subject for dinner to talk about. So if you want to talk about Golem, please do. If ever you encounter a bug, or if you want, if you have something you find weird, if you have ideas, feature requests, please do open an issue on the GitHub repo. We also have an online website, golemverse.org, that you can check. It contains packages, blog posts, and everything about Golem and other packages which are related to Golem. I'm also very happy that we now have a website for our book, Engineering Production Grade Shiny Apps. So we've been working on this book for around a year. It's about the whole workflow for engineering Shiny applications. So it's not getting started with Shiny. It's not scaling Shiny to 1 million users. It's something in the middle ground. So what to expect and how to work on Shiny projects when you have a basic knowledge of Shiny, but you want to take it, one step further. So engineeringshiny.org. It's going to be out in print, I hope, by the end of the year. So I'm going to send the manuscript by the end of this week, and let's hope it's going to be available in print by the end of this year, but the online version will always stay free on this website. So thank you. I'll take questions now.
Cool, thank you very much, Colin. Yeah, great talk. And just a point from me, I really wish that Golem had existed even sooner, because I've made so many big and overcomplicated Shiny apps, and having to do all the thinking about how to put the different things together from scratch every time is a nightmare. So I think this is just a really cool thing. If anybody's got any questions, either put your hand up in the hand up functionality thing or pop a question in the chat. We've got Doug Ashton there. I'll just unmute you a second, Doug, so you can speak. Hopefully you should be unmuted.
Hello. Oh, I saw the people in the chat first. Hi, Colin. Thanks so much. That was really interesting. I was wondering, it's not totally about Golem, but I was wondering about your experience of releasing something open source, especially something really good with lots of users. How have you found dealing with having lots of users and having something open source to maintain?
Well, I guess it's a little bit different because I'm using Golem for our projects, for our clients. So, it's just like we're improving our internal tool at the same time as improving the open source tool. So it's kind of different, I think. But yeah, the cool thing is that when a lot of people start using a package, you are going to have a lot of issues, but that doesn't mean that you're going to have to solve a lot of issues. So yeah, it's kind of, the more users, the more issues, but the more issues, the more bug you have to fix. But no, it's kind of a nice thing. I really, really enjoy, and it's always, I'm really happy that people come and say, thank you for the package and thank you for making it open source. It's a really great tool because I think one thing which is hard as an open source developer is that you never know how many people are using your tool. So I'm always happy just some people on Twitter saying, hey, thank you for this tool. And I try to do it. I try to go to open source developers I know and just say thank you and everything. So yeah, because it's kind of hard to know how many people are using the tool. But yeah, it's a nice experience.
Yes.
Cool. And we've got a question from Chris Bealey in the chat, who says that I noticed RStudio is switching to one file Shiny apps. Do you plan on sticking to two within Golem, Colin?
Switching to one file Shiny apps. Do you plan on sticking to two? Yeah. So I think we are app UI and app servers. We're two files, but most of the time I just, even if I'm doing a small Shiny app with one module, I create one module. So I'm never. I don't have. I don't think it's a good idea to have everything the same file. I think the more it split things, the better. So no, I don't think we are going to switch to one file.
Cool. So another question then from Mohammed down here is Mohammed uses Shiny frequently, but has never used modules. Do you have any resources you can recommend for Mohammed to start learning about modules?
Yeah, you can go to engineeringshiny.org and I have, chapter 3, which is a part about Shiny modules, how it works and why you should use them. So yeah, it's in the book. Please go to the book and you'll find. I guess I think it's a good introduction. I wrote it, so I think it's good.
Nice.
Yeah, I try to explain the why and how really in a comprehensive way.
Okay, great. Yeah, and I guess I'd add to that as well, like with modules, just stick with it and keep going through it because I think a lot of people find them difficult at first, and then once you get your head around it, it just revolutionises how you write Shiny apps. They're great, the best thing ever, honestly.
Yeah, because I think a lot of people are thinking of modules as reusable pieces of Shiny apps, but for me, it's just like splitting your application in smaller pieces. So basically, I think 95% of the modules are never reused. It's just like the idea of taking these big apps and splitting things into smaller pieces.
Absolutely. Another question. So, sorry, I've pronounced your name wrong here. Ocean says, thanks for the talk. I'm wondering, could you give us more details about deployment options, Shiny Server, RStudio Connect, Docker, Shiny Apps.io, and what are their respective advantages or disadvantages over one another?
Okay, so Shiny Server and RStudio Connect are products from RStudio, so you can buy licenses for these. The cool thing is that you have it inside your server, and when you are working on RStudio, you just have to click on a button and you can deploy it. So it's very easy from the data scientist point of view to share content because you don't have to think about deployments. RStudio deals with version packages, dependencies, and everything. So it's something really useful if you want to make the deployment simple to the data scientist and to data analyst or anybody without hardcore software engineering skills about deployments. Docker is widely used. If you go to any tech company or any company, most of them have already a solution with Docker running. So for example, if your company, you are working with people who do Python, people who do JavaScript, basically you can have one server that spins a lot of Dockers. And Docker is more or less language agnostic. So if you're working with, if you have a strong IT team that deploys Dockers, basically you give them a Docker and they can put it to a server. So same goes for if you use, I don't know, Google Cloud or AWS or R-ookie, so they are Docker launchers. So if you have a Docker image, Google Cloud doesn't care if it's R or if it's Python or if it's whatever, as long as it runs an application, it can work. So, but the disadvantages of Docker is that you have to know a little bit more about engineering and deployments and things like you have to care about, for example, what is the port on which I deploy my Shiny application. So you have to specify your port and make it match with, for example, Google Cloud release the port, I think, as an environment variable. So you have to take it into account. I know R-ookie does that. So R-ookie releases the port on which the software is going to be deployed. So you have to catch it as an environment variable and put it into Shiny. So you have to consider a little bit more how the whole deployment is done. Whereas with RTU Connect and Shiny Server, you just have to click on the button. It works.
Okay, thank you for that. Any other questions from anybody else, whether it's in the chat or raise your hand in the meeting? Last chance.
Okay.
Yeah.
I think there's Jonathan. Yeah. As more people try Golem, or can Golem automate the task of golemizing an existing app? Okay, so that's a tough one. Okay, so yeah, it's kind of a hard task because it's kind of hard to. It's a question we've been asked a lot: how to convert a classic app into a Golem one. It's kind of hard to come with an automated tool because there are so many ways to build a Shiny apps, and so yeah, it's kind of hard to find something that fits for every situation. Technically, if you just take your UI and your server and put it into the functions, it should work, but it might not be as simple as that. So yeah, it's kind of hard because it's hard to find a way to automate it for every, structure and every code base for Shiny.
Cool. Let's do one last question then. We've got Mohammed again just saying, is there a completely free way to deploy a Shiny app, unlimited, even if it's difficult?
Free, completely free way to deploy a Shiny app, unlimited? I guess no, because R-ookie, with R-ookie, you got, I think, like you can deploy 5 applications for free, and then so yeah, you have a function to create a Docker file for R-ookie, and it's in Golem. So if you do add add Dockerfile R-ookie, it prints to the console all the commands you have to launch to send to R-ookie. So yeah, I think you can 5 applications. You can 5 applications. But thing is that as Shiny needs a server to run, so it has to have a computer that runs hard. So these computer time, I mean, someone has to pay for it. So yeah, I think if you go for you can find I think in Digital Ocean or you can find cheap server. For example, you can find something for €20 a month. You can find something with 4 gigabytes of RAM or small server are not that expensive. But yeah, totally free. You can you can buy an old computer and let it run in your bedroom and serve the application every day. But no, as soon as you are doing Shiny, the application has to run with the server, so someone has to pay for his computer time.
Oh, well, thank you once again, Colin, for joining us. Thank you, everybody else, for coming.
Thank you for having me.
And yeah, this seemed to have worked. So if we're still in the same situation next month, we'll probably do another remote BristolR. I guess then, if nobody's got any